Hello, and this week we're going to be looking at classes. Classes begins our sort of start with object-oriented programming, and so that's going to change the way that we think about programming a lot. It's a different paradigm, a different way of thinking about programming. So in procedural programming, right, you have to think about the steps in which you would do something. And even if you encapsulate that into functions or methods, you're still sort of thinking about the algorithm what you're going to do. Object-oriented programming sort of takes a step before that, where you're actually kind of looking at your problem and trying to model it. What am I trying to do? What sort of objects are going to be involved? How are these objects going to interact? And then how can I design these objects so that they are encapsulated? They have all of the data and functionality that they need inside that object, that they can do their job and interact with other objects in the way that I would predict them to. It's a lot about design and sort of design decisions in software. And so we'll talk about that as we sort of go along in some different ideas. But that idea of encapsulation is really powerful because it makes what we're creating very modular, which makes it easier to maintain. It makes it easier to swap out a portion and replace it with something else. But before we even get to that, like the idea of just modeling and looking at a problem and saying, what is the relationship between a doctor and a prescription and a patient? And what is the relationship between a student and a grade and a course? And, because these are all objects that are going to have data and functionality built into them that are going to have to interact in our application. And so getting that right on the whiteboard means so much more to your end product than any sort of cleverness in the code itself. So then let's start with what is a class and what does it have to do with objects? A class is a template for objects that you're going to create later. So when you're creating a class, this is where you're really designing the functionality of those objects, right? This is the template. This is the blueprint that you're going to use to build these other objects, right? You're sort of defining it generically, but you know that eventually you're going to actually slot real data into those variables, and you're actually going to use those methods on particular instances of the class. And that's actually a word that we use. So when we have a class, we might have an instance of that class, right? That instance is called an object. And so let's say that we're trying to design DoorDash, right? Again, we're trying to model the problem. And so I know that on DoorDash, I have lots of different restaurants. And so what's a restaurant on DoorDash or Yelp or anything else, right? You can actually picture it because you can think in the app like, I can flip to different restaurants' pages, right? And on that page, there's going to be some information. There's going to be a name of the restaurant. There's going to be a location for the restaurant, an address of some sort, maybe a phone number. It's probably going to be under a certain heading, right? Because you can flip through and decide, I want Mexican tonight or I want sushi. And so these different genres or categories. All of these are, pieces of data that are held inside an object that represents a specific restaurant. So to sort of picture it, you are creating a class called restaurant. And then later on down the road, somebody else, maybe a different programmer in your company, is going to look at your class and use your class in order to create actual instances of restaurants, right? In fact, actually, you'll probably just set up something where some data entry person will add in the restaurants, or maybe the restaurant themselves will add in information. But regardless of how the info gets slotted in there, right? The idea is you're creating sort of the generic restaurant class, but later on, right, Fat Little Dumpling is going to be an instance of the restaurant class. The Habit is going to be an instance of the restaurant class. Chipotle will be an instance of the restaurant class. And that instance will have its own, there'll be like a slot for a name and an address and a phone number, all the things you said that you wanted in a restaurant in general when you define the class. But now you're actually creating a new object and slotting real values into those objects or into those variables inside the object so that I can then take a collection of these objects and put them into, let's say, an array list of restaurant objects that I can then display to my user and say, hey, which one do you want to choose from? You're trying to order dinner. And so that's the idea. Every single instance gets their own variable for, name, title, genre, whatever it is. They get their own menus. And let's be honest, that's probably going to be more complex, right? Because that menu is going to be an array list of potentially like objects you can order, and those things you can order are all going to have lots of different, things you can change about them. I want to make sure I get no mayo on that burger. I want to make sure that, you add extra cheese to that pizza. Things can get really, really complicated as you're creating objects designed to work together, right? But it's clear that, restaurants are going to have menus, and menus are going to have menu items, and those menu items are going to have options. And, you're looking at an array of different restaurants. Object-oriented design can seem like a big shift, but it actually makes things easier, because it's easy to think about, like, oh yeah, I want to order, this particular combo or this particular, sushi roll. It's just easier to think about things in terms of objects, and having these objects designed so that they work together just makes everything easier. And by the way, just to remind you, you've already used objects in this class. We couldn't get around it. We had to use scanner and random objects. These are not really data objects you can sort of picture in your head, right? But they are objects. They are collections of variables and data and functionality and methods that we've put together, right? Or that somebody else wrote and put together, but then we just created instances of those so that we could use those methods to accomplish things in our program. And so a lot of what we're going to see is going to feel really similar to creating a new scanner object called keyboard. And when I want to get something, I can take that object and I can say keyboard.nextInt or whatever, and I can get I can have it do whatever it's supposed to do when it gets nextInt and get some sort of value out of that. Because those objects are things that I can sort of push buttons by calling methods and have them do something. Regardless, there's a lot to talk about in terms of design, and we'll get into that as we're actually doing the demo, which we should start now. All right, here we are in IntelliJ, and I want to create a brand new class. I've got a new app here called Magic College. It's an app that's going to maybe have some college type stuff to it. And one of the things that I'm going to need for sure is a student. So I need to create a new student class. Now, the way you create classes in Java is you create a separate file. That file has to have the same name as the class that it contains. You'll notice that we have a file here called main.java, and it has a class called main with our function called main, but with a lowercase m. And that is still going to be the first function that gets called in our program. So at some point, we're going to have to come back here in order to just maybe run some tests to make sure our class is working the way that we want it to work. But this is still where your application is going to start. However, before we actually start testing stuff, we need to think about how we're going to model our students. And so I'm going to create a brand new student class to do that. The way that I'll do that is I've kind of opened up my file structure here so you can see I've got my application, which is on my desktop. In there, there's going to be a source file, or source folder, I should say. Inside that source is going to be a package, because we chose to use a package, which is why it says package.com.baker. And so I'm going to click on that package and right-click, actually, and choose New Java Class. Now, IntelliJ is going to do this for us, so it's going to be kind of easy. It'll set up sort of the main little file, kind of like it does here. It gives you a little bit of a template. But I want to call this class student. Now, by, sort of convention, classes in Java start with an uppercase letter, and they still follow sort of camel case. So if I wanted to call this honors student or something, I would say honors student with capital H and a capital S. But I'm just going to say student because I think that's supposed to represent all students, right? And so here we go. We've got student as my class name. Once I do that, I hit return, and you'll see that I've now got a second file here in my package. com.baker, inside of that is the new file student.java. So student.java opens up immediately, and it says public class student, and it has some curly braces for me to add stuff in. That is the boiler package for our new class. So now I need to actually start adding stuff to my class to say what represents a student. So for me, right, or at least for this application, a student is going to be an incredibly complex object, right? Like it's hard to express just how complex simple things are. If you go onto Facebook and you like a post, right, that is a your object, your sort of user object interacting with this method on this post, which is a separate object, and it's going to cause a whole number of things to happen. Your feed will change as a result, right? Lots of different things can happen just based on a simple like of something. And so as much as this is complex, we're going to keep it simple, right? And we're just going to choose, for me, a student is a name and a major. That's it. A name and a major, and then we'll add stuff later. In fact, I'll actually probably use this same example in future lectures as we add on additional, things. But for right now, a student is just a name and a major. That's all I need for them. So I need to create two variables in which to hold this. Now remember, I'm defining the class. So this is the template for later. Later on, we'll actually create real student objects, and those student objects will have variables to hold a name and a major. But here I'm just saying that when you create a student object, that student object should have slots for a name and a major. So we create them almost identically to the way we would do anywhere else, right? String, name, done, and string major, done. Two strings will represent our students. But we need to add one more thing. For variables inside of classes, we have to define who can access them. Now, right now, I'm only going to talk about two potential options because there's really only two potential options because we don't know something else yet. When we get to subclasses, we'll talk about more. But right now, we've got public and private. And so what it means is if I make something public, then code outside of this class. In other words, you don't have to be a member, like if you're a method, right? That method does not need to be a member of the student class in order to access the name and major. If I make it private, then you have to be a member of the student class in order to access name and major. So if I'm in, for instance, the main class, which is a whole different class, right? I could not access the name or major of a student here unless it was public. And so you'd think that that's the way we want to go, but it's not because of a design concept called data hiding. Data hiding is essentially a way of saying, I want to make sure that my data it behaves in a way that I can control. If I give you access to, let's say, we had a double for GPA here, right? Then you could just, as a programmer, change that GPA to whatever you want. You wouldn't have to think about it. Right? If this were a bank account class, you could change the balance to whatever you want as a programmer. Not talking about other programmers who work in your company. The bank account one's a great example, right? Because most people would, you have a very limited knowledge of accounting. So you would say, oh yeah, so if somebody deposits money, I need to, increase the balance by that amount. And some other programmer might make that mistake because they weren't in charge of creating the account class. But the account class may be very, big. It might be very confusing. There's a lot to accounting that most people don't know. So in accounting, if you take an accounting class, you'll probably learn that for every debit, there must be an equal offsetting credit. For every credit, there must be a debit, right? It's a, two column. It's been a long time since I took an accounting class, but there's a 2-column ledger or something. There always has to be an offset. That person may not know that, and so the person who creates the account class says, you know what, I'm actually going to make all of my variables private. And what I'm going to do instead is give you getters and setters, right? Methods that you could use to access or change those values, but that actually are a set of steps, right? I actually get lines of code so that I can make sure that you're not just changing the GPA willy-nilly, that you can't make a GPA a negative number. That doesn't make sense. The GPA can't be higher than 4.0 with the exception of some honor stuff and weirdness that goes on. But you know what I mean? I can set rules to make sure that, the behavior I want from my objects are being maintained, which means that because of that, we're actually going to make both of these private. And to make them private or public, right? I could make this public too, just by putting public there. But I'm actually going to make my variables private. And that's because I'm wanting to implement that concept or that design idea of data hiding. Now, because of that, that means that I need to make some methods for you to actually see what the name of a student is or to change the name of a student. And so we're going to create getters and setters for these two variables, which is great because I've already created two variables. Now let's create some methods that actually belong to the student class. These are our first two methods, getters and setters. So I'm going to create a getter. Now a getter is just a public, right? It has to be public because this is This is the way that I'm allowing, main to get access to the name of a student. And so it's going to return a string. Now, we're going to create the getter first. The getter is always going to return whatever type the thing is that you're trying to get. If I'm trying to create something to get the name, then it's going to return a string, right? It's going to give you a string, which is the name of the student. By convention, the method would be called getName, right? And it would take absolutely nothing, right? It takes absolutely nothing because objects already know what their names are, right? If I ask a particular instance of an object of a student, right, a particular instance of a student, what your name is, that information is already inside that object. It can just return it. In fact, that's what we're going to return. Return name. Done. I've created my first getter. If I'm in main and I have a student object, I can get the name by calling the getName method on a student object. And that will return the name for me. But I don't have direct access to the name variable itself. Again, because I might mess things up, right? I don't know exactly how intricately things are built in the actual details. We also need to create a setter. A setter is just the sort of, conventional name for something that changes the value of a name or of a variable inside of an object. So this one is actually going to return nothing, right? I'm not getting something back from it. I'm saying I want to change the thing that's inside the object. And so we'll just do that work and be done. And so then we'll call that setName. Oops. setName. And setName is going to take something, right? It's going to take a string, which I will then just call N for now. We'll talk about why in a second. All right, so it's going to take an argument. That argument is going to be the name that I want to change this student's name to, right? And so then I can just say name equals N. Done. I've taken the name for this student and set it to N. Now remember, I am still in the class. I'm just defining the template for how I want things to work later on when we create objects. But at least at this point, I could do that, right? I could go over here to main. I could create a student called Hermione, and that would be a new student, right? Creating it in the exact same way we've created scanners and random objects and other things in the past. The only difference is now I can say before I do that, because remember, Hermione is just the name of the generic student. If I want to actually set the name, I can go set name, and then I can pass the string Hermione Granger. Now that Hermione object has a name, Hermione Granger, right? If I ever wanted to print that, I can pass out, and then I can go to Hermione dot getName. Hermione.getName is going to return the name of the student, and when I run this, because so far I have very little functionality to my student, but you can at least set and get a name. And then this is the first build for this project, so it'll take a while. Should remember to just do this once before I actually start recording. There we go. And you can see it printed out Hermione Granger. So we've got something running. But now, let's add more complexity. Or I just finish out this thing. Now I should also create a getter and a setter for major. Here's the deal. I've just told you how to do it manually. If you want, you're in IntelliJ for a reason. It has a lot of nice features, right? Especially if you had created, 18 different variables. It'd be really nice if you could just right-click somewhere here in your code, choose Generate, choose Getter and Setter. Now, by the way, you don't have to choose the Getter and Setter. You can always just create one, right? If you only create a getter, then that creates essentially a read-only variable, right? Like if I have an object, I can read the name, but I can't change it. I'm not allowed to. only things inside of the class can change the name. But here I want to create both, so I'm going to say getter and setter. And the only one that's left that hasn't been already created is major. So I just select major, or I select however many that I want to create the getters and setters for. And then I hit OK, and it creates the getters and setters for me automatically. Now you'll notice, I guess, the word this. This is what was created by IntelliJ for us automatically. You can just assume it works, because it does work the exact same way as what we did. But they did it slightly differently. And that's why I named this one in. I named it in because I didn't want to create a name collision. If I said name, now this is a more local definition of name. And so when I say name equals name, this is super confusing, but also both of these things refer to this parameter, not to the actual instance variable inside of the object. So how do I do that? How do I get, to say, no, I'm going to call this name, but I want to change the thing inside the object? Well, there is a keyword called this, and this has a couple different uses, but for right now, I'm going to show you the first and most important. This is a reference to the object in which that you called the function on. Over here in main, when I called Hermione or Hermione.setName, right? You look at setName, well, setName right now makes no sense, but it was just name equals in. So Hermione Granger got passed to the parameter. So in now has the value Hermione Granger, and then I said Hermione, I essentially assigned the name instance variable inside that object to the thing that was sent. This is a reference to this specific object. So when you're creating classes, you have that this keyword. That this keyword is a reference to whatever's on the left side of the dot when you call that method. Because remember, here I'm creating the method generically for all students. Here I'm actually trying to call set name on a particular student. So this will just refer to whatever that particular student is. And if I had, a Ron and a Harry, and I were to set their names, right, then this would refer to Ron, or this would refer to Harry, or this refers to whoever's on the left side of the dot when you actually call that function for reals, right, like when you actually use it. So over here, I could just say this dot name equals name. And this is actually the much more common way of seeing it written. Because, well, if you're auto-generating stuff, and I had two different, variables that started with in, having the computer figure out then I have to just go to a second letter or whatever. It's easier to just say, oh yeah, this is name, this is major, so this dot name is different than this. But because those parameters have the same thing, that also means that when I'm in main and I want to actually create a student or do something, I can say, here, student Ron equals new student. And then I can say ron.setName, and you can see that I'm getting this little helper thing here in IntelliJ. It's saying string name. It's giving me the name of the, not where it's going, but the name of the parameter. So if I had just done in, it would say string in. In's not very descriptive, but here I can at least see that, you want the name. Again, right now it's super simple, but if this took 3 different inputs or whatever, and they were all different types, and I didn't know what the order was, that sort of little helpful thing would be nice. And I can say Ron Weasley. L-E-Y? L-Y. I'm going to say L-E-Y for now. And if you know better than me, then you can just complain. It's fine. Regardless, I've now got getters and setters, both created manually and auto-generated for my two variables. There is a convention in Java that if you want to print something out, you can create a two-string method, right? So right now I'm printing out little individual things, but I'm going to create new functionality, right? Because I can create as many methods as I want. I'm not just creating getters and setters. I can create, let's say, a two-string method, so I can just print stuff out, which is really helpful. I want to give access to this to everybody, so I'm going to make it public, not the other word. and I'm going to have it return a string. That's why it's called toString. The name of it will be actually toString. That is a convention in Java, that if you have an object and you want to just print out the values, we can say toString. It's not always implemented, but it can be. The object itself is already going to know everything that all of its inner data, so it doesn't need anything from us. We just need to implement it. And so then here I can s out. Again, I'm just system.out.println, but I'm doing it in a way that's, a little bit faster and intelligent. And so then I can just kind of decide, this is basically input, outputs, arts, and crafts. How do you want to actually view a student? So for me, I'm just going to print out name, how about I actually print out a string? Name, space. I'm going to concatenate that with the actual name of the student, so this dot name. Strictly speaking, by the way, because there is no name collision, like there's no duplication, I don't have to put this dot name. I can actually just put name. And that would work out just fine. Because in this case, the instance variable name, the thing that's inside the object, is the most local definition of name. I like putting this dot name whenever possible, just because it keeps it in my head clear that I know what I'm talking about, right? Like there's not going to be something else that comes in. It's that little bit of manual. When I'm reading this code, I know exactly, I don't have to look around for a name variable. I know that, this dot name, that's going to be in the class definition. You're looking at the name inside the object, that instance variable. I'm going to continue on to the next line, even though this will all be sort of in the same thing. And then we're going to do, let's say, how about I do a tab using the escape sequence \T for a tab. And then I will do major : space and concatenate that with this dot major. Done. This is my, I did this entirely wrong. That's embarrassing. But you could do this, just call it something different, call it print or something like that. ToString is actually supposed to return a string. So I'm not printing it to the screen, I'm just returning it. So a little easier. Does the exact same thing though. It's just, this is going to just return the string rather than print it to the screen, and then I will do that later. Why is it that a toString is better than a print method? ToString is just better because what if I want to write this to a file and not to the screen, right? A toString allows me to do that. I can send this string anywhere I want. I can send it to a file. I could send it across a wire. I could send it to a printer. I could send it, I could do anything. If it just prints to the screen, well, I can only do one thing with that, and that's not necessarily the most helpful. So anyway, toString kind of does this. And I will make that, well, actually, but now it's all, I'll never be satisfied. Me and Alexander Hamilton, right? All right, there we go. So toString, I've now defined it, which means that now in main.java, I can actually play around a little bit. Well, actually, first thing, instead of saying, println Hermione dot whatever, I'm going to say Hermione dot toString. And while I'm here, copy, paste. Actually, I think there's a duplicate I could have done that with. Let's print out wrong as well. Now, you probably realize that I'm missing something, but I'm okay with that for right now. Just going to hit print. Or sorry, run, not print. It's building, it's building, it's building. Sorry. Recording this in Camtasia and actually running IntelliJ at the same time is really tight for my computer. But here you can see, name Hermione Granger, name Ron Weasley. But the majors say null. What's that mean? Null it's a keyword that means nothing, right? There is nothing there. And that's because I didn't set it to anything. And so, because of that, we should probably actually set a major. So Hermione dot set major. Let's make her a, oh boy, what would she be? I just think that she would have a good relationship with McGonagall. So let's say, Oh, I can't remember what she taught. Never mind. We're just going to say potions because that's all I can think of. And Ron Weasley will just make his major. So Ron dot set major, and his is going to be defense against the dark arts. All right. So now they both have majors, and so when I run it, there won't be nothing there. There'll actually be something, theoretically, when you actually see this run. All right, there we go. Potions and defense against the dark arts. So now I've got these students, right? And they've got these different things that they can do. We've got getters and setters for the major stuff, and we've made this so that if I'm in main.java and I want to say ron.name equals Billy. All right, this is in red. If I hover over it, it's going to say name has private access in com.baker.student. In other words, if I'm in main, I don't have access to that. I have to go through get name, and get name can take some steps to maybe make sure that I don't put profanity into people's names or anything like that. Now, the next thing we're going to do is a constructor. So by default, Java gives you a default constructor right here, right? It gives you a default constructor, and that default constructor doesn't do much of anything, right? But it at least creates an object and kind of has the stuff to return a blank object of the class that you created. What we can do is actually define that ourselves, right? And we can actually define it so that it takes something too. So you can actually create, students much easier. And so here in student.java, let's go ahead and create a constructor. So constructors have some special rules to them. The first is that they have no return value. Well, first is that they must be public. You have to be, well, actually, there's an exception to everything. I'm thinking of singleton classes where you actually want to break the constructor. And okay, but in like 99.9% of the cases, you want your constructor to be public so that people can actually create your objects. Then once you've done that, there's the return type. Unfortunately, constructors don't have a return type, which is going to make them look weird. They have this thing called like an instance type, where essentially it's like returning a reference to the object itself. But in Java, you don't actually type anything. There's just nothing there. We go straight into the name of the constructor. And the name of the constructor, you can see it from where we call it, has the exact same name as the class. And that has to be the case. So here, we have no choice about constructor names, right? We have to use the same name as the class. But we do get to decide what we want it to take. And in this case, I wanted to take the name and major of a student right off the bat. So I can actually say I wanted to take string name and string major. Okay. Ignore the related problems. I know what they are. Although, it'd be fun to kind of check in if I click over here. Related problem usages. Yeah, okay. I know exactly what it is, but I don't really care. It's over here. We've just broke something in two different places, but we'll talk about that in a second. So, and by the way, good. Like when you see stuff pop up, it's like, why did that pop up? Am I doing something wrong? I'm doing something wrong. I'm doing something wrong. It's like, no. You just haven't completed what you're doing, right? Don't let IntelliJ psych you out. It's going to throw some red at you every once in a while. Gosh, I think Xcode for Apple is even worse. Like by the time I've created a variable, it just like turns it gray and says, this variable hasn't been used yet. And I go, I just created it. Give me a second, buddy. Anyway, so here I've got string name, string major. You send me a name and a major, and I will say that this dot name, right, equals name. And this dot major equals major. Notice I can access these things here because this is a member of the string class. Now, you can see here clearly I've broken this. The reason I've broken it is because the second you create a constructor for your class, you lose the one that Java gave you for free. That one no longer exists. And that's because Java assumes, oh, if you're creating constructors, that means that you have a specific way in which you want your objects to be created. Maybe it doesn't make sense to create a scanner unless it's tied to something, right? Like when we create scanner, we have to send something. I don't know that I can create a blank scanner. So it breaks this so that you can't call it that way anymore. You have to do it the way that they want you to do it. Now, we can solve that by simply overloading our constructor. We can create another one that says public student, and this one takes nothing. Now, the advantage of this is I can say this dot major equals, I don't know why I started with major instead of name. It doesn't really matter. I can go in any order I want, but the OCD in me says, nope, I want this to be a nice default value. What's a great default value for a name? The empty string. The empty string. Remember how like we did that before when we got nulls? Those nulls were because there was no object there. Now there is an object. The object is just the empty string. So instead of seeing null, we'll just see nothing, which is kind of what you would expect on like if you were to like display stuff on a form or something. It's like, oh, there's nothing there. We'll just put nothing. That's nice. But there's actually an even better way of doing it. And I'm going to show you by creating a third constructor, which doesn't seem to make a ton of sense. But let's say that I'm creating a student, but they don't know what their major is yet. I'm going to create a third way to create a student. You can create a student now with this new constructor that will take just one string with the name. You have to have a name. That's non-negotiable. You have to have a name. Well, actually, you can create a student with no name and you just get blanks. But like, gotta have a name. But then once you do that, what's your major? Undecided, right? So then here I can say this. Now here you're thinking, oh, I'm going to do this dot name and then this dot major. No, no, no. This can also be, this is the second major usage of this. This can refer to another constructor, right? So the other constructor, I can now just send the parameters and it's going to try and pattern match based on what I send to what it is. So instead of trying to do this work all over again, I'm just going to use this first constructor in my second constructor. So this one wants to take name and major. So I'm just going to send it the name I was just given. And for the major, I'm going to choose undecided. Undecided? Undeclared. Undeclared? Undecided? Undeclared. I'm going to go with undeclared. I actually work at a college. I feel like I should know this better, but whatever. Okay, so major undeclared. Now that means that this one could actually have just been done like this. This, empty string, empty string. Oops. They was trying to help me out. It's just too slow. So there we go. Now what's the advantage of this, right? This is sort of a design pattern where what I've created, and you don't have to do it this way. You can do it in other ways, but it's that idea of don't repeat yourself, right? Creating dry code. Don't repeat yourself. Where it's easier to maintain because I only do functionality in one location. And so here I have sort of a designated constructor. This is the constructor, the one that takes everything. And then I can have these other constructors that just call that one constructor, but send different variations for the everything, right? This one has a name, the major is undeclared. This one has no name and no major. Actually, maybe I should make this one undeclared as well. But regardless, I can create it in some different ways. Actually, I guess if you don't have a name, you're not even declared, you're nothing. So whatever. And so now I've got sort of three different ways of creating stuff. So here in main, I can say, let's do, I mean, we saved the best for last, right? Student Harry, I don't know if it's the best, but new, oops, how about I type student first? And then we're going to call him Harry Potter. I did say that in a snake voice, didn't mean to. All right, so now I've sent the name Harry Potter, and if I were to print out, in fact, if I do this, yep, Control D to duplicate. Harry should really be the Defense Against the Dark Arts major, but that's fine. We'll run it, and boom. Hermione Granger, Potions, Ron Weasley, Defense Against the Dark Arts, Harry Potter, Undeclared, right? This is because we just created them in slightly different ways. In fact, here we could even send both of these things to a student, and we would get a student with everything sort of filled out for us. So those are constructors, and a second usage for the this keyword. The this keyword can be used as a reference to the actual object you called the function on, or it can be used to kind of call another version of the constructor inside of a constructor. Now this is going to be the last thing that I add. The last thing that I want to add is something that's really important, especially if you're dealing with databases, but it's something that you have as a student and you already know it, and that's an ID. So I'm going to add new functionality to my class. And I'm doing so in order to display a new tool or concept, right? We need to create a student ID. So what is a student ID? The fact is, my name is Brian Baker, right? When I worked for a bank here in town, it was a national bank, like there were 5 or 6 other Brian Bakers just in the Northern California region alone. It was ridiculous. Like, I have a super generic name. We cannot use names to identify students. For one, women sometimes change their names after marriage, and so then that causes issues. Whether they choose to hyphenate or anything, it doesn't matter. Like, the name has changed, right? That would be like your student ID changing. Like, oh, I'm, Brian Sutherland now. Okay, well, that's great, but like Brian Baker got a degree, but I don't know that it's you. Student IDs essentially allow us to get rid of all of that. It's a unique identifier for a particular student object, right? Or particular student, sorry, you're not objects, you know what I mean. A particular student on campus. So I want to create one. Now, how do we give them out? It's actually pretty simple. Every new student that we enroll in the college, we just give them the next number. So your number was not randomly decided. It's just the next number. If you look at my employee ID, which is my old student ID, it has like 4 zeros in front of it. It's because it happened a while ago. Yours probably doesn't. It's a higher number, right? So then what I'm going to do is actually try to do that. I'm going to say that when you create a student, that we're going to automatically assign you an ID based on the number of people we've given out IDs to before. That's easy. First thing I need to do is every single student needs to have a space to hold an ID. So this means we're going to create a new private int called ID. Done. Now every single student object has a new ID for the student, right? But think about the number I need to give out next, right? That's going to be based on the last number I gave out, based on the number of students we've enrolled. Do I need to keep that number with every single student? Like, to know what the next ID I should give out is? Like, no. Like, every single student doesn't need to know that information. That information isn't really associated with a student, with an instance of the student class, so much as it's kind of associated with the class itself, the thing that creates students. Like, that's the thing that needs to keep track of what the next number they should give out is. So we have a concept for that, right? Instead of putting this variable inside of every single object, so every single object has a slot to hold potentially a different version of this number. There are no different versions. There's only one version of this number. We know the next number we're supposed to give out. And we're just going to put it one time in system memory, or not system memory, but in program memory with the class itself. The class will own it, and it'll just be the classes, right? And so we use the keyword static for that. You may be wondering, hey, why did we get rid of static when we're creating functions inside of a class? It's for this exact reason. Set name, get major, toString, all of these constructors are meant to be called on a particular instance of a class. This is something different. We're going to create something that is not associated with an instance of the class, but with the class itself. So this is going to be a private, because nobody needs to know it, outside of the class, static integer called next ID. Right? It is just the next ID you should give out. So we have this static thing. It's only going to be stored one time in our program, and it's going to be stored with program memory as part of the class. And it's not every single student. Every single student will have slots for 3 variables: name, major, and ID. But next ID is not in every object. It's not an object variable. It's not an instance variable. It's a class variable. And by the way, other languages make that a lot more easy by just calling them class variables and instance variables, like in Ruby. But here we just know that static is sort of owned by the class and potentially shared by all of the instances of the class. But there's only one version of it. So now, if I wanted to actually implement this next ID, where would I want to implement it? Well, probably do it in the constructors. Now, because I have 3 different constructors, but I have this idea of a designated constructor, right? Then it's pretty easy. All I have to do is just change it here in this version, because these other 2 versions just call this version. So this is the one real version of the constructor that actually does anything. If I go up here, first thing I should also do is initialize this variable to something. I don't need to worry about initializing this, right? But these will be initialized by the constructors. But the class itself never gets a constructor, so I should probably initialize that variable to something. I think by default Java will initialize it to 0, but 0 doesn't really make a whole lot of sense to me because I don't want to have a student 0. Like, you shouldn't have a student 0. And in fact, I want my student ID to be at least a certain length. So I'm going to start with 1. 1, 2, 3, 4. Yeah. 5. So we're going to start with student, 100,000. And then from that, we'll take that 6-digit ID and we'll just keep increasing. In fact, if we want to, we can say 1, right? 1, 0, 0, 0, 0, 1 is our first student. That should be the next ID we give out. Then we need to change this so that it gets updated later. This sort of thing is only going to happen when we first run our program. After that, we're going to be hopefully modifying it as we run our program. So here we are, back to this. I'm here in string.name. Now I have to do this.id, which is now going to do this for all versions. Remember, I don't have to choose an ID for either of these. I don't have to choose an ID here. The ID is going to be automatically assigned. It's going to be assigned to next ID, right? It's not this. In fact, if I did want to actually do it, I would be specific. I would say student.nextID, right? Because it's connected to the class, not to an instance of the class. You don't have to do the student.nextID. Again, I kind of like that because it sort of tells me this is not a local variable. This is actually a static class variable. But anyway, so now that I've got that, the next thing I need to do is say student.nextID, ID plus plus. Just increment that number so that the next time we create a student, we're creating a student with the next ID, right? It would be 100002, and then 100003. Every time we create a student, we're upping that next ID and giving every student a unique identifier. So now we've implemented IDs, kind of. There's one last thing I need to do, which is over here. Actually, after this .name, I'm going to concatenate that with, how about a space, an open parentheses, and then close that, and then we'll add the this.id to that, and then we'll concatenate that with, drop this to the next line. If you know what I'm doing, it'll make sense, but otherwise it won't. That and a space, and then actually, I can just leave those 2 strings together. So then after that, close parentheses. Basically, after the name, your student ID will be in parentheses after your name. This is just input, output, arts, and crafts. Again, you make it look however you want, I don't care. And so then here we go. We've got our little toString, and so now if I go back over to main, I haven't changed anything about the way we constructed it because it doesn't matter, right? Those IDs are given out automatically. And I hit play, and we should get after it builds, perfect. Hermione is student 01, 00001, 10002 is Ron, and then Harry is 100003. This is undeclared major. So now we've got ways of doing all this. And by the way, you actually can have static methods as well. Those would be methods that you would call on the class, not on the an instance of the class. In fact, when we created methods the first time, we always put in that keyword static. And we did that actually specifically because we were in main. And so then if it create other methods inside of main, the main class, when I call them inside the main function, main is inside the main class. So it assumes the main dot and then the name of the function. So you didn't have to actually put the main dot because we were already in main and we made everything static. But more importantly, you didn't have to create an instance of main, which makes no sense at all, in order to actually call the methods using dot notation. You were able to just call the method, have it do its work. So anyway, that's the last bit, is static. Static is a way of making either a variable or a method associated with the class rather than, and have one version of it rather than every instance of the class. And so that is it. That should be enough for your first couple projects in classes. And if you have any questions, feel free to send them to me. Have a good day.